Hey everybody, this is section 3.5, parallel lines and triangles. We're going to talk about some properties of both of those. Okay, so your first postulate that we're going to look at is basically through any point not on a line, so point P is not on line L, there is only one and only one line parallel to the given line. So there's only one line that we can draw through point P that would be parallel to line L. Okay, and so that's basically what this is saying here. There is exactly one line through P that it would be parallel to L. All right, your other theorem that is in this section is that the sum of the measures of angles in a triangle is 180 degrees. Most of us already know that. So if we take angle A plus angle B plus angle C, it should equal 180 degrees if we have a triangle. All right, so actually let's use that triangle angle sum theorem to be able to find x, y, and z. All right, so first of all, if you look at triangle ABD, we only have one variable missing. If we look at triangle BDC, we have two variables missing. So we want to work with a triangle that only has one variable missing. Okay. You could work with the bigger triangle in this case first to find z, but it's just going to be easier to find x first. So to do that, we know that there's 180 degrees in ABD. So we're going to basically subtract 59 and 43 from 180. So we get 78 for angle ADB, or for the value of x. All right, now that we know the value of x, x and y actually form a linear pair, so they have to add up to 180. So we're just going to take 180 minus 78, and that'll give us 102 for y. All right, so now that I know angle y, I can now look at the other triangle that makes up the large triangle, which is BDC, and I know angle y is 102. So I know angle y is 102. So I can now use the triangle angle sum theorem to be able to take 180 minus 49 minus 102 to give me z, which is 29. Okay, so it's just building on the diagram. All right. Okay, your next theorem here says that the exterior angle of a polygon, okay, is basically an angle that's going to be formed by a side and an extension of an adjacent side. So that's the exterior angle of a polygon. You'll see a picture of that in just a second. Okay, and for each exterior angle of a triangle, the two non-adjacent interior angles are its remote interior angles. Okay, so if we look at this first picture here, angle 1 would be an exterior angle. It's formed by a side, okay, and an extension of adjacent side. So this would be the adjacent side, this would be the side. Okay, and then 2 and 3 would be the remote interior angles because they're non-adjacent to angle 1. In other words, they don't form a linear pair with angle 1. Okay, here's your next diagram. So we have angle 1 would be your exterior, 2 and 3 would be your remote interior because they're not next to angle 1. Angle 1 would be your exterior because it's formed by an extending adjacent side and a side. 2 and 3 would be your remote interior angles. So in each triangle, angle 1 is an exterior angle, 2 and 3 are its remote interior angles. All right, let's actually use that theorem here. So the measure of, or let's actually talk about the theorem that uses those two things. The measure of each exterior angle, okay, of a triangle equals the sum of the measures of its two remote interior angles. So angle 1 is just going to equal angle 2 plus 3. All right, so we want to find the measure of angle 1 here. So angle 1, remember, is equal to the measure of angle 2 plus 3, 2 and 3 being its remote interior angles. Well, 80 and 18 are remote interior angles to angle 1, so angle 1 is simply 98. All right, and then find the measure of angle 2. So 124 is actually our exterior angle this time. 59 and angle 2 are our remote interior angles. So subtract 59 from 124 and you get 65, because then you can add 59 plus 65 to equal the 24. All right, and then we have this problem here, it's just another problem similar to the last one. This is actually a problem out of your book on page 174. So we'd want to find the value of x. Well, x is actually a remote interior angle to angle 80. So we're going to take 80 minus 30 to give us 50 for that one. All right, and then our last one here. So in a triangle, angle 1 is the exterior angle, and angle 2 and 3 are its remote interior angles. We want to find the missing angle measure. Okay, well, first of all, you want to draw yourself a picture to make more sense out of it. So now we have that picture again. 1 is the exterior, so we know that 1 is just going to be angle 2 plus 3 to give me 130. Same thing, use the same picture for number 2. You're given angle 1 and angle 2 this time, so you're just going to take angle 1 minus angle 2 to give you 38 degrees. All right, and that is your 2 theorems from that section. We will see you later.